Okay, in this video we're talking about the ideal gas law. The ideal gas law helps us determine how many moles we have. And this is used when we are not at STP. Because we know that when we are at STP, that 1 mole is equal to 22.4 liters. So this equation comes into play when we're not at STP. We can also use it when we are at STP, but it's just not necessary. Alright, so the P, of course, stands for pressure. The V stands for volume. The N stands for the number of moles. And the R is the gas constant. And the gas constant is in your reference packet. Okay? And it has to match based on your units of pressure. Okay, so if you look in front of your reference packet, you'll see several different values for R. And those all have different units of pressure. And so that's what we have to use to match that up. And so T, of course, is temperature, which just like before, has to be in Kelvin. And in this equation, volume has to be in liters. So previously, volume didn't matter as long as both units were equal units on the same side. But in this equation, they have to be in liters, and that's because of the value of the gas constant. Okay, so in our example problem, we have a sample of gas has a volume of 2.850 liters. That, of course, is our volume at 22 degrees Celsius. That's our temperature, and a pressure of 740. So how many moles of gas are present? So we'll plug this into our equation. P is 740. V is 2.850 liters. T is 22 degrees Celsius. So if we add that to 273, we get 295 Kelvin. Alright, so PV equals N, which we don't know, or R times 295. So the value that we choose for R has to correspond to our millimeters of mercury. If we look on our reference packet, we'll see that that value is 62.4. And you'll see the units are millimeters of mercury times liters over moles times Kelvin. Alright, so now we solve for N. And we'll divide, so we have 740 times 2.85 divided by 62.4 divided by 295. And we get 0.1145697. And so we have here 4 significant figures. Here we have 3, and there we have 4, so we'll keep 3. So the 3 significant figures, we have 0.115 moles of gas. Okay? If this gas were carbon dioxide, what would be the mass of the gas, right? So we have 0.115 moles. If it's carbon dioxide, we would just convert that using the molar mass of carbon dioxide, which is 44.01. So we multiply by 44.01. And to our 3 significant figures, we get 5.04 grams of CO2. Alright, so I want you to pause, and I want you to try this problem. And then when you're done, we'll come back and we'll work it out together. Alright, so we're going to use our ideal gas law and plug in the values. What's the pressure in atmosphere? So we're looking for pressure. And then exerted on 3 moles of hydrogen gas at 4 degrees Celsius and 5 liters. So our volume is 5 liters. Our number of moles is 3. Our R value has to be in atmosphere because that's what we want our pressure unit to be in. And so that's 0.0821 times our temperature in Kelvin, so 40 plus 273 gives us 313 Kelvin. And so then to solve for our pressure, we'll divide by 5. Right? And again, our significant figures, we have 3, 3, and 3, so we're going to keep 3 until we get 15.4 atmospheres. And again, I know it's in atmospheres because of the value I used for R. Okay? And that concludes our video on the ideal gas law.